Okay, hello everyone. My name is Jeffrey Ouellette, and I'm an Open BIM consultant for the built asset industry. I'm here today to host the industry perspectives on Scan-to-BIM panel discussion on behalf of the Open Design Alliance. I want to thank all of our panelists for joining us today. And before we start this discussion, I'd just like to go around the group and have everyone introduce themselves, basically with your name, your title, and your company. So start you off, Andrew.
Sure. So I'm Andrew Fox, Sketch Partners, architect at Sketch Partners, been here about 8 years now.
Great. Dan?
Dan Smololo, Director of Process Innovation at the Walsh Group.
Jim?
BPC Manager with Pencil Phelps for about 9 years now.
Great. Hector?
Hector Camps here, FiCube. I specialize in building lifecycle management.
And Gustavo?
Hi, my name is Gustavo Pardo. I'm the Design Technology Manager for Perkins Sismonds Architects.
Great. Again, thank you, gentlemen, for being here. So we're here to talk about this idea of scan-to-BIM, where the results of a LiDAR scan, the use of laser imaging to scan the environment in 3 dimensions and generate a data set also known as a point cloud, it's then converted into building information model geometry. And usually it's some kind of proprietary platform format like an Autodesk Revit or a Bentley Systems MicroStation file as examples. But ODA has seen the growing demand for such a workflow. And that's what we're really here to talk to you all about is finding out what those workflows are, your experiences in them, what you think you need, what you'd like to see happen in the industry. And they're really interested in helping the BIM software developers create more powerful tools so that they can enable faster and more accurate scan-to-BIM conversions. As I said, I think, there's already software out there. We've seen this sort of come about, especially in the last 10 years. We've seen a rapid development and maturing in the last 5, but it still seems like we're not there yet. And so I'd like to really, start this conversation giving an overview of sort of where Scan-to-BIM usage is now. So my first question is really, looking at your practices in general, how often is your company seeing projects where there is a need to create models from these scans and the point cloud data? And think of this in 3 ways. How does this frequency compare to 5 years ago? And do you think it's going to increase in the future? So let's kick this off with Andrew.
Sure, yeah. So within our office, I've worked on probably 10 of these projects now that have used some form of scanning, converting into something, whether it's gone into BIM with probably about half of them. Some of the early ones were scanned to flat CAD drawings. And there's been a couple projects where we've just received the point cloud and it hasn't really gone beyond that. I would say that, so within our firm, the section that I'm working on is largely renovations and preservation and restoration projects. There is definitely an increase in demand for the use of this. It's to the point that basically every project now in the last couple of years has had some form of scanning, whether it's to scan to BIM. The last project was a substation in a basement with complex floor and ceiling and wall conditions. And maybe at its largest scale, we scanned an entire auditorium space, 6 floors, and for many future projects, but for the first was for a seating project where we really needed to have a great understanding of this curving bowl of seating that then needed to be modified for ADA upgrades, and all the slopes needed to be very precise. So to answer your questions, there's definitely demand, and I think it is, as long as we continue to do renovation projects, it will definitely be an increased demand too.
Great. Dan.
Yeah, I agree 100% with Andrew. Majority of the time that we're leveraging this technology, there's kind of three reasons. One, the owner's driving that. They require it in some form of specification, and we're providing that, whether that's a as-built turnover or something along keeping up with as-builts throughout the building cycle of the project. But where we see the greatest value is in those retrofits, those renovations. Walsh has three different verticals. It's our building group, civil group, and our water group. And water, time and time again, when you're massive upgrades, how are you retrofitting this existing facility with new pipings, new filtration systems, new processes? So really having a granular view on how this is going to integrate into the current process and procedures is very difficult. And, you can go out there and take a tape measure and measure it, but, that really doesn't provide great hindsight when you're throwing these models together, as well as how you're going to get this information or this equipment into these spaces. Other places that we're seeing in distribution centers, everyone's kind of trying to retool themselves or upgrade their distribution centers that are already packed full of distribution equipment. So how can you get the best fit or best space layout in that? And laser scanning has been great in that aspect.
Okay. Jim?
Yeah, for us, it's very similar. We've deployed point cloud technology for the last decade, via either laser scanning directly or increasingly with drones to capture the larger type sites. And I would agree that that this process it takes a lot of time. So really going into the project, it's that understanding. Typically, it depends on our trade partners, whether or not they have that capability to deal with the point cloud directly, or if we need to execute that conversion to a BIM model. We see it a lot in our aviation airport type projects, large spaces where we're getting a lot of benefit from that. Your laser scanning can capture above ceiling content, which is extremely valuable during coordination. And then just the ability to convert that to a 3D. We typically shoot for Revit or Autodesk-based programs, but it's definitely dependent on the owner. But the ability to work in that environment, as opposed to how heavy these point clouds are, it's definitely an advantage that we have, and it's something that also feeds a lot of the other technologies, such as augmented reality devices with the HoloLens. Those run quite well with a very light model that's been optimized. And so it's just that mix where we see the opportunity. We'll definitely go for that. And it also just depends on the project team.
Okay. Hector.
Yeah, so these are all really good responses. I tend to look at it from the building lifecycle perspective. So I always like to start with why. Why do people want to do the scan? In the front end of the design construction process, you have the as-built condition. So a lot of the front end laser scanning work that we've done in the past has been around capturing the as-built condition. For example, we did Miami International Airport, which had an extremely large footprint. It's an airport, of course, and it was built where nobody really trusts the as-built documents because they go, I need 10, 20, 30 generations. They're like, you want the 1975 version, or you want the 1982, or do you want the 1994? And they recommend you look at all of them because they all have different pieces of information on them, but none of them have the truth. Yeah. So because you can't trust the as-built documents that we're inheriting from the history of that building, and people want the confidence to truly know what's out there, we've been scanning to document the as-built condition. Another interesting reason why we've been scanning, of course, you can take the professionals and bring them to the field, but it's much more interesting to bring the field to the professionals, especially when you have remote distributed teams that could be anywhere in the world. The people who are, for example, in this case, that were working on the baggage handling system for MIA, they were out of Michigan. So they couldn't really fly to Michigan all the time to see what's actually out there. So this was a very effective way to bring the airport to the team that was offsite and remote and needed remote access to see what's actually out there. So that's part of the reason we've been doing this. The second reason we do this is to do field verification. So we can really get involved with constructing from the model. We try to drive a construction-driven process from the model, and we built. There's BIM, and then you also have VDC,
Right.
Virtual Design and Construction, which gets into more of the construction fabrication side of the world of BIM. And since we're driving construction from the model, we need a high fidelity model. We need confidence. We need fit form. We need to make sure that those structures, those baggage handling systems, whatever they happen to be, are actually going to fit correctly the first time. And we rely on the model to be able to perform that and be able to do that.
Gustavo.
Well, Hector, you make my outline difficult. You really outline everything in such a great way. So for us in Perkins Eastman, we're a large firm. We have large projects. Existing conditions are fundamental. We really need to get existing conditions. There is not enough interns to go to a place and measure. And I would say we probably can divide this thing in three areas. One is coordination. You can say efficiency that goes with productivity, and then precision. So if we're talking about an airport, or if we're talking about a feed out, it's the same. We need that precision. Another thing that Hector mentioned that I think is fundamental here and critical is that so many times we go to a place, we get the drawings, you will get the really old AutoCAD drawings, or you really get the old BIM model, and as soon as you go to the side, you're like, whoa, what happened with that window, or what is that wall? and if we think about going back to that efficiency and productivity pocket, by the time that your team goes back to the place, or by the time that you have your first coordination call, and you realize that the wall or the window is not there, you probably pay for half of that 3D scan. So if we think about that, in that call, you're going to have probably 10 high-profile employees. That's a lot of money plus the time. Something for us that is important is the scale. We have some projects that we have towers that we want to do a retrofit. We're definitely going to do that. But there is also a niche in a practice area that we call workplace, and there is some smaller spaces, and we see the drones, as Jean mentioned. We see the point clouds, we see all type of 3D scan, but there is no a tool that help that small niche. When you have to 3D scan something, you don't want to send your team there, but you need to capture the space. So there is a lot of opportunities in the field. We have seen increasingly. I would say probably 100% of the projects that we have that are existing conditions, they're doing 3D scan. It's not, it's a pretty easy decision.
It's a given these days.
Yeah.
Yeah. Okay, excellent. So you've all mentioned the types of projects that you use that you typically are doing Scan-to-BIM. Maybe you can help also describe what is your process. I mean, are you going out and doing the laser scanning yourself with your own units? Are you hiring somebody third party to do it? Are you then getting the point cloud data and translating that yourself, or is that also a third party service? What kind of things are you relying on? I'm going to skip over to Dan.
Yeah, so probably every variation and then some of what you just mentioned.
Okay.
Depending on the complexity of the project, the availability of our scanners, that's always a difficult thing to approach. We have multiple scanners within our organization, but we have a retrofit project comes up. That's just like a full-time FTE that's sitting there, and that's being leveraged on that project. One of the banes of our existence is when we hear we need to perform laser scanning on that project, and then the first question that comes to mind: are we creating the model? Oh no, the architect's creating the model. No problem. We'll go scan that. We're completely fine with scanning that project because that's the easy part. Scanning and registering those points, no problem. The complexity of really developing that model, that's time consuming. And unfortunately these days in the industry, you're closing up one project, starting up another project simultaneously, and bidding a project in between the two of those. So it's very difficult to kind of stop, do all those iterations and go through it. we will. We have, and we've done that before where we're scanning and we're creating those models. Traditionally, we're hoping that the architect, it's part of their scope, or we will bring on third-party consultants or contractors in that we have trusted relationships with, and they'll create that model from those scans as well. So we probably use every variation of it, and we really determine what's the best utilization and time of this model. Knowing that this project is going to be a very complex retrofit, well, we should be all hands on deck on that project. If it's something that it's going to be continuous scanning and it's not necessarily for a model, it's more for as-builts, we might have a third party come out and do those scans every couple of weeks because it's not kind of part of the build-out workflow. It's more of that close-out FM deliverable at the end of the day.
Great. How about you, Hector?
Well, I want to pick up where Daniel left off. So the FM deliverables are really interesting asset. So our customers are becoming savvier as time goes by, and ownership is saying, hey, wait a minute, we're really interested in this scan beyond the construction. So if we ever need to go back there, we want to see the scans. We want to be able to kind of see the bones of the building at different milestones, and we want to be able to kind of turn back the wheels of time and be able to see the building in its different historical points. So I think this is a really big point. And a lot of people are starting to associate data and information with the point clouds as well. So I think that's kind of an emerging thing that we're starting a trend that we're kind of paying attention to, and we're seeing that tracking the historical development of the project through the scan is becoming a record document of sorts that ownership is now starting to expect and wants to associate with the model and the documentation. So we're seeing a lot of that. The other thing that we do a lot of field verification, as Daniel also mentioned. When we have the construction schedule, we have milestones. And those milestones, we generally look at the schedule and we try to figure out when it would be a smart time to go out there and do some field verification. In essence, to make sure that the building is going on track and that we're getting it built right the first time, and to get some foreshadowing of what's going to happen if we continue this trend and build out this way. We're doing this with the scan. So we'll, the MEP goes up there, the mechanical systems go up there, we want to scan. They pour the decks, we want to scan. So we're basically following the construction schedule and scanning at different milestones.
So are you doing that with your own in-house equipment, or are you using a third party to do that?
We lease our equipment from Faro or from a third party. So we do our own scanning, and we've been using more of the automation where we're trying to use more of the auto registration capabilities, which cuts some time for us. But if we're in a snag and we have a very complex scan to put together, we may rely on a third party to help us put the scans together, or basically what's called registration.
How about you, Andrew?
So from the architect standpoint, we've seen a couple different variations. We've never done our own scanning. We're usually contracting out. It's either with the general contractor or it is coming from an outsource firm of some sort. And then from that point, once we've done the scan, we have both modeled in-house, and we've also outsourced the model, or the general contractor has provided the model from their scan. It's our preference not to do the make the conversion ourselves, because it just isn't time and cost effective to do it for us. But we've done it. It can be a couple-week process for very complex things, if not a month-long process for much more complex things. And as far as recent projects, as I said, we've moved into this outsourcing process. There's a couple firms in the city that we work with regularly now who will do the scan, create the BIM model. We usually like to see the scan and the BIM model, even though the scan file is usually large and sometimes overpowering for our network. There's a lot to be gained from being able to overlay both of them over each other as we move into the project, and being able to see, what areas do we need more detail, what areas, they're not always 100% accurate. Where can we catch really important places where the scan and the model might vary, even because the building might vary a little bit, like it slopes from one side to the other, and it couldn't be accurately gathered within a BIM model.
Yeah.
So yeah.
How about you, Gustavo?
Well, again, it depends on the scale. If it's something that is small enough, we just go out there and just take some measurements. Most of we don't have the equipment. Everything that we do, we outsource. We're great designers. We build beautiful buildings, but 3D scanning is not an area that we want to spend our time.
Yeah.
And the same thing that Andrew mentioned, for us is it's better if we just get the full model already in BIM, and we just import it into our models. Something that I want to mention is that even when we get the 3D scanner, and this is a project we have in New York, we got the 3D scan from the client. We do some field measurements, and really quickly we realized that even the 3D scanning from the client was different to the existing conditions. So I think there is and I see this should happen in the future somehow. Facility management, the whole process of us building those beautiful 3D models, having the information that Hector was mentioning, and we see all these QR codes in the rooms when you can start seeing what is inside that room. But it should go farther. We should find a way to track how our buildings are evolving through decades.
Mm-hmm. Yeah. I think, Jim, you mentioned a little bit, but are you doing this fully in-house, or are you kind of, as Dan mentioned, is you're utilizing whatever you can, whenever you can for particular projects?
Just the complexity of the process. So as far as the laser scanning piece, that's pretty much done 100% in-house. Laser scanning has become a pretty important process to our construction in general, just for these renovation type spaces, to get an accurate as-built, but also to check the quality of slab placements and document all that during the construction process. But a big point, it's something we've toyed with as far as the model conversion. It's something that we used to handle all of that in-house. The software years ago has been developing where there's automatic feature extraction. But what we found is, particularly with piping type systems, the software will create those elements, but then you spend just as much time QCing and making sure everything fits properly, that we weren't really seeing the efficiencies to make that process go. And that's kind of why we're here talking about this. The industry's been chasing this magic button where point cloud allows us to capture more data than we've ever had on the construction site, and then with drones as well. But the ability to efficiently convert that to a model is something that really holds a lot of people back, because not every person on the site has a supercomputer that can handle that point cloud. And so for us, it's a mix, just like everyone else. For smaller type efforts, we'll handle that conversion. But for massive projects such as airport terminals or baggage handling systems, we have a lot of third-party partners that we're comfortable with using. But even so, that's working with different groups and getting that process dialed in between us and the partners we use.
I want to do a little follow-up, if you don't mind. So what would be the role of automation in 3D scanning? Because we all face the same challenge. When we go and we scan, we get a lot of information that we probably don't need. So, for example, I get a 3D scan, I come with a bunch of piping they're not really relevant for let's say, the scope of work that we're doing. I wonder if in the future some kind of algorithm is going to start understanding what is piping, what is a wall. It should be something that start filtering those things. We have seen some automation where you understand what type of geometry is there and say, okay, this could be a wall, and it throws a wall there. But it should be something that it moves farther. I don't know where the technology is going what direction it's going to go. But now I'm just looking at the windows. It is a window, has transparency, so it will create a material. I don't know if anybody has any experience or have seen any out there that start moving towards that direction.
I've seen some work being done with LiDARs where the LiDAR scan can tell what's a car, what's a building, what's a tree, what's the ground, and you can filter out the LiDAR scan. Well, it can take out the vegetation from the scan and just give you the floor condition, for example. So I would imagine in the near future, we're going to be able to see something similar to what you're talking about, Gustavo, with connecting it to building objects. So again, I've seen that at the larger scale when we're talking about scans of cities and what dams and this sort of infrastructure. I haven't seen it all the way down to the granular level of a building yet. I mean, I have seen some experimentation with it, but it's sort of in the beta stages, what I've seen so far.
Yeah.
So it sounds like everybody sort of agrees that some of the biggest problems that you face so far is, you get a lot of information, you get a lot of data from these point clouds, and sometimes it's too much. It's either too much in that the data set is so large, it's unconsumable by hardware, by the systems that you have,
right? Or
it's just a lot of noise. I mean, it's a hell of a lot of noise, right?
Yeah.
And in these scans, they can vary their precision input to 10 points within a square inch or even smaller, and can go larger than that. So, of course, the larger the area that you're scanning, the more points you have, and that can be very dense. Sounds like cost and the time associated with A, making the scans, and B, making those conversions is a very big deal. Obviously not every type of stakeholder, if you're an architect and you're focusing on design, that may not be feasible within your firm. Or, sounds like on the contracting side, you figure out ways to make it work because that is a part of your process. That is a fundamental part of what you do in being able to do the scanning, but maybe conversion isn't always necessary. Or if you could get conversion on top of that as an easy gain, then it would be much easier to justify. Okay, so I think that does a pretty good job of laying the groundwork. So ODA is in this realm of trying to provide sort of these core technologies that fill these gaps, right? If you look at what ODA has done so far, they've provided a lot of interoperability toolkits for the industry. So, getting DWGs converted from different systems. Now they have an IFC toolkit. They have a Revit toolkit. They have a DGN part of their toolkit. And the whole idea is to enable this information to travel between platforms. So this approach essentially from ODA is to say, well, could we do the same thing in this Scan-to-BIM, range? And, an attacklet that says, well, let's provide the tools and the platforms for anybody and everybody to be able to use, and as a cost to their membership. But what do you think about that approach? I mean, does that seem to make sense to you rather than sort of waiting for, each of the individual vendors and sectors to just sort of figure it out?
Well, yeah, I think there's a need. So it's interesting because one part of this is how do you consume the scan data, right? One of the issues that we've always had, of course, when you talk about laser scan of an airport, you can imagine how difficult this is to consume. In every sense, hardware, just transferring the information, making it accessible, making it available, bringing it into other systems. So we obviously need more optimized ways of being able to make that data available in a wide range of platforms, in a wide range of environments. Everything from a tablet computer all the way up to your smartphone. How do we get a laser scan on a smartphone and make it consumable? And so we're working on finding more optimized ways of delivering this data to our clients and making it consumable, especially over the web and on mobile devices. And remember, one of the big reasons people do this is called metrology, right? It's all about, one use case is just being able to measure. and pulling information off of that scan data, and being able to do that from any device. So there's, of course, you also have being able to geo-reference the scan to a space. So when you're standing in a location and you want to take your smartphone and kind of like use augmented reality to kind of see what's in the ceiling and be able to pull in the scan data, this sort of thing, and tying it back to a geo-reference point. And again, being able to tie into mobile devices. It's all about making it consumable and making it extensible throughout the design construction process. And anything you guys can do in that direction would be fantastic.
Anyone else?
And I would definitely say the burden of entry. That's the toughest thing in our industry, regardless of whatever tool or device or workflow. Especially in this one, where you're talking about when you enter this space of laser scanning, you can get third parties, you can lease them, but if you truly want to have a holistic program in-house, buying the equipment, it's a six-figure entry cost. And
yes, sir.
To get to that point, just to understand something, that's a pretty massive uplift. So once you get there, you start scanning, you get this data set, and now, okay, you have to register it in one of dozen different solutions. Okay, I have this beautiful wire mesh now. What the heck do I do with this? Well, now you got to take it into another program, and then you have to edit it, and you have to build a model. So it's how do we simplify this even more? How do we make selectable meshes? How do we make that where we're working is more in the mesh and less on modeling it? That becomes the active participant, if you will, for the end game. But you're seeing movement on the laser scanning side of things. Everyone's got the newest, latest, and greatest cell phone or iPad, and they now all of a sudden have laser scans on them. Nobody knew what the heck they were going to do with it. It was for the AR, so you can have a little dancing rhino on your desk. But then people in our industry started being like, wait a second, I can now work with an interior designer. I could scan my apartment, send it off to an interior designer, and get a beautiful decoration of my apartment. Well, if we could do that on our personal level, why aren't we trying to holistically approach this in our industry to make it easier? If I can go out there with an iPad, all my foremen have iPads out there. Let's start scanning this. Let's start tying this into different third-party solutions, production tracking, things like that. So I think the sky's the limit when it comes to developing solutions for this workflow, because it's an underutilized, and the burden of entry is so high that not enough people are playing here yet. So it's kind of a majorly underutilized principle in our industry, and I think it's worthwhile and it's worth the investment to start understanding what it could do for you and your projects.
Yeah, and I think this idea that the ODA approach speaks a lot to, one of their partners is Building Smart International, and the Building Smart International philosophy is, well, one person can't solve it all, so why don't we all work together to figure out the best solution for everybody for most of the time? Figure out that 80-20, right? And so that, you're getting everything solved 80% of the time, and that 20% outlier will figure out eventually, and it may be a, strange use case, but working together to figure it out and then sort of harmonizing the workflows and harmonizing the results across a larger spectrum of stakeholders and processes and things, I think has a lot more benefits to the industry than just saying, well, if I've got 50 different companies that are going to try to do this and they come up with 50 different solutions, now all of you in the marketplace have to figure out, well, which one of us 50 is the best? And it's like, well, what if none of the 50 are good? Then what do you do, right? And how do you get them to work together and say, well, maybe these 5 are close, or these 15 or 25 are close. Now, can you all work together to figure out what's the best out of that? So I think Jim, Dan pointed out some interesting, and so did Hector, about how this evolves then into the future workflows and the potential, from their workflows. What do you see?
That we've seen, there's processing ways to host your point cloud on the web. Makes it very simple to view, to share data, even on the capture side with drones, and then with We've been playing a lot with robotics, with Spot. You have ways to automate that capture process as well. Makes that whole piece really efficient. But to your point, one of those big gaps in the market is just on the software side. Just the ability to efficiently take this massive amount of data and convert it to a much more efficient model that you can work with, that you can share with the team, that you can consume, that down the road this feeds your AR process, this feeds future scanning and the ability to perform inspections with point cloud against the model. It's that upfront investment that takes a lot of time on projects. For us, for huge projects, we might spend a month preparing this model. So that's, to your point, I think that's definitely somewhere where the industry as a whole would definitely benefit. There are a lot of different groups out there that have different tools, and I'm sure like most of you, we have to be pretty agnostic. We have to use a lot of different tools. There's a lot of different conversions to get what you need. Each has their strengths, has their weaknesses, and we're constantly going through that process on the scanning and the software side just to see, okay, where's the industry at? Who's bringing new technologies, new potential to it? But the ability to bring all those collective ideas together in a simple, efficient solution, I think is an amazing challenge, but definitely something that would benefit the whole industry.
I will follow up with what you're saying, James, and I see the same thing. So one would be the part of visualization that gives access to clients and everybody in the team to really quickly understand the space, or even take a simple measurement. Now to be able to access that data, it is pretty heavy, and it is hard to anybody in the team to just open it and take some quick measurements. And the other thing would be translation. So how you take all that point cloud and you make it accessible to whatever platform you're going to use it. We cannot restrict our users or whoever is working with this data to only work in one specific brand software. So we cannot say, well, if you get this one, you use this tool to translate the data, and now you need to use Revit, or you need to use ArchiCAD. So it needs to be something called like IFCs, that is it can work across any platform, and you can open this file in a SketchUp if you want, or Rhino, and you can get the same precision. But it's all about being efficient.
So Dan mentioned something interesting about, and kind of a question is, depending on what your use case is, that conversion of scan to BIM might have different requirements, right? So Dan was saying, for us, I would love to use a mesh, right? And maybe in some cases, just the point clouds are enough. In some cases, a simple point cloud to mesh conversion enough. In some cases, you go that step further in which you say, well, no, I want actual constructive solids geometry that's typical in a BIM system that, gives me parametric control over all of these features. I mean, so it sounds like there's also a need for having that user control over how far to take a conversion or what direction to take a conversion, not just the fact that you have to convert it anyways. Any other thoughts on that?
Well, on one side you have the software generating the geometry, but that's, in the world of BIM, it's a little bit more complicated because you can make something that's a cylinder look like a pipe, but then you have the building object, which is a pipe, right, and has more attributes connected to it. Is this an electric pipe? Is it a gas pipe? What kind of conduit are we looking at? So it goes a little bit further than just generate the geometry. You have to generate the building object for that geometry that's appropriate for its use and function of what it is. And I don't know if the software is smart enough to tell that's an electrical conduit versus this is a fire protection pipe here. So I don't know if we're there yet in taking it to that level of granularity. It would be cool. I mean, artificial intelligence might be able to get us there. But just based on geometry alone, I don't know if we can go the full mile with it at this stage with the building object situation.
Right.
So go ahead, Andrew.
Sorry, I was going to say there's probably a step before that where where maybe the future and not quite attainable yet is being able to read the point cloud and come up with an actual BIM construction type level of detail. In between there is kind of perfecting the point cloud to mesh system, which could be useful even going back to our recent project of trying to decipher between seats and floor in a very densely packed theater floor, and trying to find the little bits of floor that managed to be scanned between the seats and then create a recognizable mesh out of that, which was something that we didn't have the ability to. It may exist out there, but we certainly didn't have the ability to automate that, and it became just a process of cutting a ton of sections and trying to figure out where the floor was among all the seats. And then also to add to some of the other things that have been said here, we have also been seeing clients now wanting to see, say, point cloud data, and short of me sharing screen with them, there are a limited number of ways to actually send them, say, 300 gigabytes worth of information that they would then need a software to do anything with it.
Yeah. Anyone else want to add? Okay, so one last question I have, and some of you have already touched on this, is sort of the things of looking to the future and how to use them. I think Hector had brought up a great example of, using like AR with phones. And we see more and more now, VR trying to incorporate the models. I've seen examples now of people trying to overlay those scans and your view and the models, using an AR perspective. These are, small startups, or, they're just trying to push it out there. But I think a large part of it then comes back to, well, what does this mean for your services to your customers, as well as what happens to you internally? If somebody had that ability to, incorporate AR with the Scan-to-BIM and then being able to display this stuff, does that sort of change how you think about the information and then how you use the information?
Yeah, my gut instinct on something like this, I think we're going to see this information become more extensible. And like you mentioned, Jeffrey, augmented reality and serving that information up on whether that's Google Glasses or whatever next level technology comes, iPhone or a shield, augmented reality shield in front of your helmet, whatever that is. As everything is going to the cloud, and point clouds are going to the cloud as well. And if we could run those on servers that are running in the cloud and serve it up to a mobile device, a lightweight mobile device, whether it's your smartphone or a pair of smart glasses, whatever the tech is in the near future, I think there's going to be a market for consuming this type of data after the fact into field operations, into facilities management, into life safety, or even first responders going into a burning building scenario where they can know a little bit what's in the walls, kind of add the X-ray layer vision that has come from the scan data, or a combination of scan data and BIM model. So I think there's a feature for serving that up. I'm not sure exactly who delivers this as a service, but I think there's a feature for consuming this data downstream. And maybe that the building department now has a requirement to consume this data and make it publicly available. I don't know, but I think there's definitely a feature for that.
That will get into a point that, so what's the format? So maybe what is here is just developing a universal format for point cloud data that can be consumed in different ways. Yeah. So then you can get, the fire department has all the equipment, but that's not the right format. So it should be some kind of like IFCs again, it's some kind of international format that anybody can have access to the data.
I think going back to the original question, I think the sky's the limit on what you can and cannot do with it. We're talking somewhat hypotheticals here, so it's on the most granular level, what's in it for me? So how is this going to benefit me in my workflows? What are the benefits to improving the constructability, improving construction, telling that story? We don't just willy-nilly do things because it's cool and neat. There's a purpose behind it. So what is that purpose, and how can we get to that end result? And just like the previous question on persona-based stuff, mentioned fire departments, everyone watches NCIS and this and that, and the fire department shows up and they pull up the 3D model of the building and this and that. Well, we all know that that's not a real thing, but what if, what if we can get there? There's interesting discussions on the Apple AR tags, the new tags that they have out there. It's built on their AR kit. So is Apple secretly mapping our environments without us knowing it? So, how do you get into this realm of real-time city diagnostics? You get into digital twin a little bit. You get into constructability reviews. If I can really do that, if I can pull the building up using Google goggles, tear it apart, throw in the 3D or throw in the laser scan, pull different segments off, add a whole nother floor. You get into this really hypothetical world of these what ifs. But it's going to take that burden of entry to get there, to really explore how we can start to leverage this technology even more. And what are we, the six of us on this call, what are we not even thinking about that we're underutilizing in this realm? And how can this truly evolve, as this is now the replacement of the slide ruler that is now the cell phone in everyone's pockets? Because back in the day when we were taught math, you're never going to have a calculator on you all the time. Well, and we know that that's not the case. We all have calculators on us all the time. So in the future, now that we have laser scanners on us all the time, how can we start to evolve these processes and procedures to benefit ourselves and everyone in the entire AECO process?
Hey, I'll offer one up. One of the biggest banes on a construction project is the lag time of inspections to occur between stages, right? And what if the inspectors didn't have to be there on site in order to get it done, right? What if you didn't have to worry about that kind of scheduling? Instead, the inspectors could use those laser scans to do the inspection and then sign off on them too based on that, or make their notations and everything that they would do in person instead of say, okay, well, by the way, we're going to have a robotic LiDAR scanning done at the end of every workday or at the end of every work week. Can you work from, X date and then do an approval on that? I mean, to me, that sounds like that would be a win-win for everybody, right?
I think that's the separate panel. That's the Scan-to-BIM lawyer's perspective. So they'll need to come onto that one. So,
well, yeah, and I think even with the Scan-to-BIM, and I think a couple of you touched on it, the accuracy of the results, right? Is what does that accuracy mean? Accuracy means everything depending on what scale that you're working at, and then what is the ultimate purpose or goal of what it is that you're scanning. If you are trying to make sure that you properly locate, all of the walls in a building that may have shifted over the years, and now you find that you have a non-conforming condition, that begins to pop up these ideas of, who's responsible for that? Where does the liability lie? Where, these things. And of course, we all know in our industry, liability and all that is, one of the biggest concerns everybody has, because that equals money. That, risk and that liability, can bring down entire projects, if not companies. Yeah.
It's always one of those conversations. Oh, look at the time. I got to go.
Well, anyone have anything final to add before we sign off?
Well, there's one thing that I'm paying attention to.
Let go, Jim.
Go ahead, Jim.
I'd say we're pretty close on what we're just talking about. The ability to automate the capture process, to automate the registration, to push that data into the cloud and do that as kind of a daily check of the site, that where you can have robotics that can scan your project, can register, can push it to the cloud, can perform that analysis and see how everything is. those pieces are just about there. They're very close. And it's just to any new technology, the key is how efficiently we can get that data available. And then it allows us to use these different form factors. AR, when it first came out, was extremely limited just because you have a small computing power within the HoloLens device or whichever device you're using. And we can see now with efficiencies in the modeling processes, we can get those models much smaller in size. The compression allows it to be seen on devices such as our phone. As the devices improve, as the accuracy improves with these different solutions, it's definitely going to be deployable. The big question is how we make it more efficient. So like the Scan-to-BIM process, if it's taking a month, then it's not going to be viable in most use cases. Whereas if we find ways using artificial intelligence to make that process more efficient, repeatable, and precise, then it allows us to, with great confidence, to deploy this to our different technologies, and it becomes part of our workflow because it's something that's simple and adds value.
Ultimately, somebody has to pay for that month. Somebody has to. It's got to come out of somebody's pocket. Hector.
Yeah, I was going to say, we're paying attention to 5G, and all those 5G towers are going up there, and all this new technology is being equipped in self-driverless vehicles that, as far as I understand, are basically scanning as they're driving along and getting all kind of data about the built environment around the vehicle. And that's happening hour after hour, day after day, week after week, year after year. I can just see that's a massive amount of information is being collected of the built environment around us. Somehow we're going to have to leverage this kind of data, and I'd like to tap into that at some point. And so I see there's a big wave of big data coming from autonomous vehicles, whether those are drones flying around or Uber helicopters that are going around picking people up in the future. They're collecting data of the built environment, and that's being repeated on a constant basis. So I think if we can tap into that and optimize that, it could be a very interesting use of LiDAR data that could be available to us.
Excellent.
So I think that's something to look at.
Well, gentlemen, I would like to thank all of you for your time and giving us feedback on this subject. I'm sure the ODA development team and the members will greatly appreciate your input as they look to tackle this issue. Hope you all have a good rest of the day, and look forward to talking to you all again, hopefully in person one of these days. But thank you very much.
Thank you.
Thank you, everybody.
Bye-bye.
Be well. Great panel. Take care.
Bye-bye.